Good morning, sunshine. All right, we're going to talk a little bit about the project registers and timers. I want to give you a little bit of guidance here. Just going to read through the problem statement, make sure that you understand what is being asked of you. So this is just an exercise in coding and register management. So we've already dealt with all of these programs. So all of these programs should already be established in your in your, not your folder, but in your pendant. All of these pendant programs have already been created. This was 13 and lab 13, and this was lab 14, where we split them all out. So you have all of these programs already written. So now it's just a matter of taking these programs and running them the correct number of cycles, and then establishing time registers that would count the amount of time spent for each of those. So we have a register for shapes. That's going to be register number 2. So when I say time register, there's no such thing as a time register. A time register is just a register that holds a time value. So that's not a thing. There's just like there's not a count register. There's just registers. So I use some registers for counting, and I use some registers for keeping time in this lab. So that's what those refer to. So we're just going to create a program that runs shapes, the shapes program twice, and circles 3 times, square 3 times, triangle 5 times. We're going to use these registers to keep track of those the counts of those programs. We're going to use these register locations. These are just register locations, right? So this is register number 1, 2, 3, 4, 5, 6, and so on. And then register 11, 12, 13, 14, 15. This is a little bit of a trick. Okay, so you cannot do this in one step. I will tell you that much. You'll figure it out. You cannot mix addition and subtraction and multiplication and division. So how are you going to accomplish that? So I'll leave you to puzzle on that just a little bit. But you're going to need something in addition to what I've specified here. But you'll figure that out as we go. All right, so we have not dealt with timers. And you will need to understand how to use timers. Very straightforward. You're not going to have any problems with that. Just to demonstrate how you might approach this project, there's fundamentally 3 ways to address this project. One way is just to take your shapes program and just copy it, paste it twice, and then take your circle program, copy and paste it 3 times, square 3, triangle 5, and then put timers in there, put a timer in for shapes, timer in for circles, timer in for square. Use 1 timer for each of these, and then we do a conversion here with the total time, and because timers are in seconds, and then we perform these arithmetic functions on the register values, so forth. All right, so that is brute force way. That will get you a C, right? So that's the easiest possible way to approach this problem. Doesn't really require any thinking. You just brute force it, right? It's probably going to take up, I don't know, over 100 lines of code, maybe something in that ballpark, but a lot of lines of code. Right, so the other way to do this is to use the loop function, right? So don't know what I'm referring to, go back and look at some of the previous labs where we've installed logic that will loop a program for so many cycles, and then goes on to the next lines of code. So you can use a looping program, a straightforward looping strategy for each of these. So you create a 2 loop code for this one, 3, 3, and 5 loop code for triangle. All right, and then you just list those one after the other. So first loop, second loop, third loop, fourth loop. Right, so that would be a strong B, right? Definitely doable. Maybe even let's say that's a low A. And then for the overachievers, what I'd like to see someone tackle is a really concise approach to this, an elegant approach that would use the minimum number of lines of code, that would use something called indirect addressing in order to accomplish this. And indirect addressing is when you use registers to actually identify registers. So a register identification can be performed by actually using a value in that, a register value that would identify the register itself. So I'd like to see someone approach it in that manner using indirect addressing. Now let's talk about timers. Let's just pull up one of the existing programs, and let's just demonstrate how timers are used. Timers are pretty easy actually. So let's take a program like Shapes, and we want to know how long does it take to go through one cycle of the program Shapes. So we just do an insert and next page. Let's see, I'm turned on there. Yeah. Okay. And miscellaneous, enter, and timer. And there's a timer. So you have, I think it's 20, I believe the number is 20 timers. So we're going to use timer number 1, enter. And now it asks, what do you want the timer to do? Well, I want the timer to start. So these are your options: start, stop, reset. And I think you can set it equal to a value as well. All right, so we want it to start here. So that's start. And then if we go all the way down, shift and down, we want the timer to stop. So I add a line of code for the timer to stop here, timer 1 stop. And now I want to capture that timer value. So I'm going to use a register. So enter register, so register equals, and we're going to say register equals, so R, and I'm going to use register 10, something that I know is not being used at least in my program right here, and equals, and I want to set that equal to a timer. So if we just keep going to the next page, here we go, timer, and we set that equal to timer 1, and enter, and we're done. So now if we go back up to the top and we run this program, it's already selected, so this should be selected, and we just run it. And it runs, it looks like shapes, so triangle, square, circle, all ran. So now what I should have is, when I go to my register, my data register, is a value in data register 10 for how long it took that program to run. And it took that program 24.8 seconds to run. All right, so that's the way it works. That sounds long. I'm going to have to double check the units here, but this is the time value for shapes. All right, good luck with that, and hit me up if you have any questions.